Alright, I realized when I created the data structures and algorithms album, I didn't talk about the most basic things, that is data types, because you have to understand data types before you go into understanding the data structures. So with data types, you can choose like what your programming preference is, and mine is Python, and here are the different data types within the context of Python programming. So yeah, here's an outline. You have the numeric types, which includes integers, floats, complex numbers. And then you have bool, which is like true, false. And then strings, anything that's wrapped within quotation marks. Lists, arrays, tuples, and dictionaries. So yeah, I'll go in depth within each of the sections. This is just an outline so we can make sure we stay on topic. Okay. Numerics are, as they sound, numbers. So, but there are different numbers that Python accepts. So value 2 equals value 3 equals. And this first one, I'm going to give it a whole number, 5. Second one, I'm going to give a decimal. Oops, 4 is fine. And then this third one, I'm going to give it a complex number. So what a complex number is made up of is real plus imaginary. Okay, spelling's hard. There you go. So 5 is the complex number and 3j is imaginary. And with Python, instead of using I to denote that it's imaginary, it uses j, and I think, like, I'm just gonna speculate. It's not the truth, but it's my guess. Python uses I for like other functions, and you'll see it in like, especially like looping. You know, if you write a for loop, it can look something like this: for I in, and then whatever the list of your for loop is going to be looping through. It could be for I in colors. And then you can also have I in the array, where it means every element in the array. So yeah, anyways, I think to like not confuse what the I does, they just change the imaginary to be denoted with j. Anyways, so, oh gosh, spelling is hard. We're going to have an F string that says the first value is, and we're going to grab the value 1 variable, whatever is returned or assigned to value 1 will be returned, and the data type is, I'm going to say type, not square. We need curly. Now type round, and then value 1. Yeah, there we go. So now, oh no, there we go. Now it says the first value is 4 and the data type is integer, written in short as int. So let's just copy paste this for value 2, value 3, swap out first for second, and swap out value 1 for value 2. Yeah, I'm not lazy. Now swap out first for third, and value 1 for value 3. Value, great, it can auto detect. There you go. Now it prints out all of these values, what they are, and what the data type is. So the first value is 4 and the data type is int. The second value is 3.3 and the data type is float. The third value is 5 plus 3j and the data type is complex. Alright, so let's say you want to parse out and make sense of the complex number. Let's assume you don't even know what a complex number is and you simply see this somewhere where it looks like a math equation. But yeah, so let's import CMath. C math. And then we're going to print value 3, which is up here. I don't need to, I mean, like, I could copy paste this in this cell, but it remembers. So let's just leave it like this and say dot real. Yeah, and then we're going to print another that is value 3. We're going to print the imaginary, there you go. So now it's going to tell me the different parts of this complex number. There you go. Now, in the print statement, it seems arbitrary that it's just printing 5 and 3. So let's have it print a sentence with those variables filled in. Now we know the real part of the complex number is 5. The imaginary part of the complex number is 3. Yeah, so let's move on to Bool. Bool is short for Boolean. And let's say you and I are playing a game. I'm going to have a number in my head. My number equals 10, but you don't know that. Your guess is going to be 2. Now, if your guess is equal to, not just a single equal sign, because a single equal sign means you're assigning something to the variable. In this double equal sign, we're asking, is it true or not? So is it true that your guess is same as mine number? So if it is true, if your number matches up with mine, then print correct. Else wrong. Print wrong. There you go. Your number was 2, mine was 10. 2 does not equal 10, so it's going to print wrong. Now, after many guesses, you guessed 10 as well. Now it's correct because 10 equals 10. It is a true statement. And that's all there is to Bool. So now let's move on to strings. Actually, sorry, let me back up. Why would you even need a Bool anyways? Let's say you're trying to create an automation script. And within your automation script, you're going to set some checking mechanisms before you do all the, I don't know, let's say like data manipulation, right? You want to validate that the inputs are as you want it or they're true before you continue and do all of the rest of the hard work. So that's where like Boolean is useful. Let's see, let's do strings now. I'm going to have a variable, instead of value 1, value 2, I'm going to have variable A, variable B. So with variable A, we're going to have 1. Variable 2, we're going to also have 1. But what's the difference? Variable A is an integer and variable B is a string. And how you know that it's string is by the quotation mark. Anything wrapped in quotation will be a string. So yeah, technically, you know, this can be alphabet too, or it could be alphanumeric. It really does not matter. As long as it's wrapped in quotation marks, it becomes a string. So we're going to print print A. Okay, print B. There you go. See, the output is 1 and 1, but what if I ask, what is the type of A? And what is the type of B? It's going to return something different. Type B. Now needs closing. There you go. So it says type A is integer and type B is string. So let's make it a little more readable, and by asking this. A is calls on the A variable, and B is calls on the B variable. There you go. A is integer and B is string. let's get away from just numbers and do actual like alphabets. So we're going to do the famous print statement in all coding tutorials, hello world. Now print hello world. You can make, this is a static way of printing strings. You can also use print, hold on, before we even do print, you can also do something that's more dynamic. So first, dynamic. First, we're going to assign to this variable that's called to who? To the world. Not World Cup app. And then print using the F string, hello, and then pass in the variable to. So now it's going to say hello world. So this output is the same as this. Oh, I should uppercase this for grammar's sake. Now run. Hello world, hello world. Now what's nice is instead of like deleting the entire print statement just to retype who you want to say hello to, all you have to do is just change this variable. Let's assign it to Stella because that's the dog behind me. And now print hello Stella. Yeah, so that's the difference between static and dynamic string print statements. Now I want to do I want to show some other cool functions. So let's say we're going to ask for my name. My name is Claire. Oops. Now we're going to print my name and it says Claire. Great. What if I want to uppercase my name and like shout it at you? Then we can do dot upper. And this upper is native to Python, so you don't have to like import or download any external packages. Just do name.upper and it'll uppercase every single letter within my name. Let's say we want to do lowercase, name.lower. And this is where the upper and lower casing might actually be useful in terms of like real use case at work. If you're trying to clean up data, right? Let's say you're a running race coordinator and you're trying to gather all the registrators who's coming to this particular race. Well, on this electronic form, there's going to be people who will fill out their names a little differently. Some might do, if you ask for a full name, they might do like last name, comma, first. Some might spell everything all in uppercase because it's an official form. They feel like they need to just uppercase everything. Then it might be like shouting your full name. Or some people might just not care about grammar at all and just type it in as it is. So to get every data to be standardized, maybe you don't want 4 different combinations of different ways people can spell their names, right? You want to, let's say, do all uppercase on their names, and then you want to trim all the white spaces that are either leading or trailing. And then let's say you have another set of table. You have a table that has all of the registration members, and then you have another table that might be called profiles table. And you're trying to join those 2 tables on a specific key, and that key could be the full name because that's a unique ID to the person. You should standardize those values, and these are just 2 easy ways you can standardize. Now let's use my full name as the example still equals, and the user being me, I'm the user, and I want to be cheeky and be like annoying and say this is my full name. So I'm going to add a lot of spaces beforehand and a lot of spaces after my name. So now I'm going to print full name, colon, and then we're going to pass in the variable called full name, which contains the user input. And, oh shoot, I need to put the F in front. Now it knows to call the variable. There we go. Do you see all this all this extra space, if I highlight this whole thing, you'll see like there's leading and there's trailing. If I don't highlight it, it looks okay. It just looks like a big gap. So how do we standardize this? Well, we can do full name strip, full name dot strip. And what this function does is it just automatically will take all the leading and all the trailing. I'm gonna call this clean full name. Ah, shoot. And then instead of calling the full name, we'll just call it clean. Print and call it clean. Now, see the difference of these two? Yeah, so that's another way you can standardize your data. Let's say within your data, you don't actually need the full name. Let's say you just want to extract last names. In this case, let's just use the full name again and assign it to the last name variable. Last name equals the clean version of my full name, because this first iteration of cleaning is done. This is what we need. Now we'll take the clean version of my name and say replace the old pattern with the new pattern. Old, comma, new. This is the syntax. So what's the old thing that we want to change? So this is my old craft, comma, Claire. I want to replace craft, comma, space, or sorry, what do we want? We want my last name, sorry. So then we're going to take out the comma, the space, and the Claire, and just swap it for nothing. Replace it with nothing. Now print out my last name. It's gonna be craft. Nothing trailing, nothing following, comma, space, Claire disappeared. All of this got replaced with nothing. So yeah, that's one way you can extract a particular part of the string. Same is true if you did the first name. All you would do is where the old pattern is, you can just say, let me just do it. Instead of last name, we'll do first name. Oh gosh. First name will be, we want Claire. What we don't want is craft, comma, and a space. And then we're going to replace it with nothing. There you go. So now you have Claire. Let's move on to lists. With lists, you can have alphanumeric data types within lists. So let's say I want to do colors. So I'm going to stick with strings for now. But what makes a list is the square brackets. Now everything inside it are called elements. We're going to have the primary colors, red, yellow, comma, blue, comma, green. Now let's print our colors. There you go, red, yellow, blue, green. Now if I want to extract a particular position from this colors list, and I'm aware that red is first, yellow is second, blue is third, green is fourth. Let's say I want to pull out yellow because it might be my favorite color. Then you can do print colors. Do the square brackets, and you can decide what position you want. Now, about the positions or the indexes. In Python, or I think in any coding language, you start counting with 0. So 0, 1, 2, 3. So if I want the second element of the list, then I just subtract 1, because counting does not start from 1, it starts from 0. So there you go. Now yellow is extracted. What if, let's say, I want to count, instead of starting with red, yellow, blue, green, I want to call it in reverse. So you can do print colors, and then you can do this -1. Oops, -1 has to be inside the square bracket. And print, oh, I didn't spell this right. There you go, and it spits out green. So indexing is really helpful because each of these get assigned to like a position, like a seat number. Now I'll go into tuple. Tuple is kind of a mess because it's like a list, it's like an array, but it'll take anything and everything. It's immutable, meaning it can be changed. Anyways, let's just get into it. So tuple, I'm very creative with my variable names, huh? Tuple 1, we're going to have these elements. We're going to have an integer, then we're going to have a string. Let's go with blue because blue is my favorite color. Then we're going to go with a float, so we don't need quotations. 3.4. Print tuple 1. Huh? Oh shoot, just 1. There we go. Simple tuple up there. Now let's make another tuple of just random things. And I'm too lazy, so I'll copy paste like this, swap out 1 for 2, swap out 1 for 2, and just swap out the numbers. Let's do 5, and I want red, and I want 3.8. There we go. So print tuple 2. So these are different than these, but now I want to concat the two tuple. So instead of doing tuple, not tuple 3 equals, instead of like statically copying paste like this, and then comma like this, right? I can just call on the variables tuple 1, 2, tuple 1 plus tuple 2. Oh, let me print it. And it's going to do the addition for me. Gosh, spelling is so hard. There we go. Let's say I want to do nested. Then you can do nested tuple equals. We're gonna have the blue out here. Then inside there, let's add some integers. 1, 2, 3. Let's have another list. 4, 5, 6. 4, 5, 6. And let's print nested. Nested tuple. Manipulating the tuple, you can print it out as it's written in this way. So blue came first and then these sets of numbers. You can also do a reverse where you go from the back. You're indexing from 6, 5, 4, 3, 2, 1 blue. So let's do that. Do nested tuple square brackets -1. So we're going to index through everything but from 6. Oh shoot. Nested. Oh, it's not going 6, 5, 4 because the first element within this set is 4, 5, 6 and 1, 2, 3 blue. Yeah, anyways. So that's just like reordering essentially. Now onto dictionaries. You can have, again, you have these sets that are called key value pairs, which is essentially what is a word and what is a definition, like that. But instead, they call it key and value because this value is associated to this key. Now you can have key, value, value, value. Oh, I hate this word, value, value, right? This is where you can have multiple key values, pairs. But let's go, let's start with just the simple 1 key to 1 value. I actually have this on my notepad over on the other screen, so I'm just going to paste it here. So let's say we want Dunder Mifflin and we want the name and the role. So you can print it out. Michael's a manager, Pam's a receptionist, Jim is a salesman. This is based on like season 1. Now, if you wanted multiple things about a particular actor or actress, actually these are character names, so you can have multiple things. You can say Michael is a manager and he's a male. Pam is a receptionist and a female. So see how there are 2 values tied to the name, which is the name is the key. He's a manager and he's a male. And you can do that by typing key. Let me do it like this. Oops. You have key, value, comma, another set of keys, another value, comma, and you can go on to the 3rd key to the value. And yeah, and then once you print it, then down here, let me just quickly explain. I'm saying print the name, which is the first key of this. I'm looping it, so I'm saying for each employee, which is each of these curly brackets that represents an employee, and so on. So for each employee in this dictionary variable, Dunder Mifflin, print the name, the first key. Let me just comment this. Print the first key, then print the second key, then finally print the 3rd key. And then separate each set of keys, which is their name, their job title, and their sex, by commas. And then, but not just commas, we need a space in between so that it's easier. So like this. Gosh. If it was like this, then it'll literally print out Michael, comma, manager, comma, M. But we need it like this, so that's Michael, comma, space, manager, comma, M, just to make it readable on our end. Let me just print it out so you can see why I have separation by like this, right? If we have it just like this, it's going to print out like this. It's not as user friendly. We can maybe do dash, and you'll see, oh, Michael's the manager and a male. So there you go. This is an overview of the basic data types that comes with Python programming. And all of these data types are going to be the foundation for understanding data structures. Papa, that's a kitty's food. It's not your kibble.